Let's talk about various different types of lists in Java. As I alluded to from the beginning of the chapter, a list interface inherits from collection, which inherits from iterable interfaces from the libraries. You see these hierarchical inheritance structures from list all the way up to collection and iterable. Overall, this Java library has a rich set of classes: abstract lists, abstract sequential lists, array lists, so on and so forth. Abstract lists is a class in Java that is part of the collection framework. This one implements the collection interface, a skeletal implementation of the list interface to minimize the effort required to implement this interface backed by the sequential access data source, such as the array. Every single one of this list has a story behind it. You can read more into each of these specific lists and see how they're used. Both stack and vectors in general are the concrete class implementing the list interface, which of course implements collection and then implements iterable. A couple of the linked list variations that you see in the industries includes these things. So you have doubly linked list. This is the list that allows you to, with the regular front and the rear, instead of traversing from front to the rear, you can also traverse back. This one is a very efficient doubly linked implementation. You can also have a circular one. Basically entails the rear of the list moves to the front. As long as you still have space to move around it, your tail always goes back to the front. Your front and the rear pointers, we've been using this kind of implementation details to keep track of the front and rear for enabling queuing purposes, as well as the stack. Keep track of the front and the rear for that to happen. If there is no sense of ordering, of course, you can use the regular syncly links list. Problem with this one is since there is no front and the rear labels, whenever you need to insert something towards the end, you have to iterate from the head to the end. And that iteration and traversal itself is O of one. You can also have these multi-level type lists. This is advanced stuff that you're going to have a design for. These pointers go from one side to the other. And if you make a modification, for example, on this part, that changes what this points to and also changes what this points to. This could get pretty complicated. Hash map uses something like this, where you have a list of objects. Each of the elements inside the object maps to another key value pairs. So this is a linked list as an array of nodes. A, B, C, D itself is just a class. You can also have a list that points to this array. This is more like dynamic versus static allocations. So this static storage means every time you need to add another node, basically dynamically instantiating another one. This E, make sure that this null goes right there. This is dynamic storage, dynamic allocation of nodes. You can also have a list with a static storage. Static means you have to allocate your information up front. Every single one of these elements is allocated dynamically, but the static storage means that you can pre-allocate array of 7 elements, and you can keep track of your nodes being the array structure as well as the first. This is an integer one, all wrapped in this giant class in there. Buffer internally is just these nodes. This is the difference between dynamic storage and static storage. Let's take a look at the difference between the two implementation styles. So static allocation of array means you have to specify the number of elements that you want inside the array from the very beginning. This array like this has a fixed size upfront, let's say 100. Why would you use a dynamic allocations, as needed? Sometimes we go for the array route because programming languages do not support dynamic allocation of reference types. And this is possible for some of the procedural languages. Purportedly, this is one of the reasons. There's also other reasons, and that is about speed. Dynamic allocation of array, especially when you have a high throughput system where you have hundreds of thousands of requests coming into the system per second. For every new request, you have to store at least its data inside a dynamic object. And that object has to be dynamically created. And that is very, very slow. So every time you use new means dynamic memory allocation. This happens inside this heap memory space. Dynamic memory allocation is slow compared to static allocations because the amount of process that involves in creating information inside a heap, allocating the data, that is just slow. This is the reason why people use array instead of that linked list approach. The desire for static allocation is one of the primary motivations for array-based link approach. We drop our assumption that our lists are of limited size in this section. So this means that if you're using static allocation approach, the assumption is that this list is not going to grow as needed. If that's the case, we can always enable the enlarge method that allows you to dynamically resize the underlying array buffer. There's no way that you can just directly double the size of the array without creating a new one, copying the old one back into it. So this is a super costly operation that will slow your computing down. Applications should not add elements to a full list. This is another assumption that you can use. You would not have a situations where you have a full list with more elements still adding to it. The assumption is when you're at capacity, you're not going to expand your array. You'll have to start deleting stuff. As long as your application do not have that considerations ever running into a full capacity, that you're capable of rotating the elements. One example is what we call LRU, least recently used. This one is essentially a list that allows you to insert elements into it. But at the same time, you will be able to look at also the age of each data. If they're old or getting stale, you can start evicting it. Eviction happens when it runs out of the list. This list capacity tells you how many elements you have in there, which elements are the oldest. You can start evicting it. So there's a lot of these type of implementation that happens that do not necessarily involve use of dynamic note insertions, but array-based linked approach. So this is the reason why we're using the array-based implementation. We'll move on and talk about other list variations as well.